Hi and welcome to John's Maths book. In this video, I'm going to be looking at finding the modulus and argument of a complex number. If you like the video, then please hit the like button and I'd be delighted and honoured if you'd subscribe to the channel. Without further ado, let's go to the whiteboard. Let's clarify the concepts of modulus and argument for a complex number. The modulus of a complex number, often written as the complex number with bars either side and referred to as mod of that complex number, represents its length or magnitude. We can visualize this on an Argand diagram. Consider the complex number a plus bi. When plotted on the Argand diagram, we move a units along the real axis and b units along the imaginary axis. The modulus of the complex number corresponds to the length of the line connecting the origin to this point, which forms the hypotenuse of a right-angled triangle. Therefore, we can calculate the modulus using Pythagoras' theorem. So the modulus of the complex number z, where z is equal to a plus bi, is the square root of a squared plus b squared. The argument of a complex number z equals a plus bi, denoted as argz, is the angle theta that the complex number makes with the positive real axis on the Argand diagram. This angle is typically measured in radians and is conventionally restricted to the range where theta is between negative pi and positive pi. Note that theta is strictly greater than negative pi. The argument theta of a complex number indicates its direction relative to the positive real axis. A positive argument theta corresponds to a counter-clockwise rotation from the positive real axis. These angles occur when the complex number lies in the first or second quadrant of the Argand diagram, shown here and here. The maximum positive argument is pi radians. A negative argument theta corresponds to a clockwise rotation from the positive real axis. These angles occur when the complex number lies in the third or fourth quadrant of the Argand diagram, shown here and here. The minimum or most negative argument is greater than negative pi radians. Let's now solidify our understanding of modulus and argument by working through some examples. In our first example, let's find the modulus and argument of the complex number 3 plus 7i. If we plot this number on an Argand diagram, we see we have 3 units on the real axis and 7 units on the imaginary axis. These two sides form two sides of a right-angled triangle. The third side, the hypotenuse, is the modulus, and to find the modulus, we need to find the length of the orange line. To do this, we can use Pythagoras' theorem. So the modulus z is equal to the square root of 3 squared plus 7 squared, which is equal to the square root of 9 plus 49. And therefore the modulus of 3 plus 7i is the square root of 58. To find the argument of the complex number 3 plus 7i, we need to find the angle it makes with the positive real axis. So in this case, the angle it makes is theta, and theta is part of this right-angled triangle. So the tan of theta is the opposite side divided by the adjacent side, which in our case is 7 divided by 3. So the argument theta, or argz, is equal to 1.17 radians. In our second example, we'd like to find the modulus and argument of the complex number minus 6 plus 3i. If we plot this complex number on an Argand diagram, we see we move 6 units along the negative real axis and 3 units along the imaginary axis. These two sides form two sides of a right-angled triangle. The third side, the hypotenuse, or the orange line, is the modulus z. To find the modulus, we need to find the length of this orange line. We can use Pythagoras' theorem to do this. So the modulus of z is the square root of 3 squared plus 6 squared. So this is the square root of 9 plus 36, which gives the modulus to be the square root of 45. The argument z of the complex number minus 6 plus 3i is shown as theta on the Argand diagram. But in this case, it's simpler to calculate the value of alpha and then subtract the value of alpha from pi to give the argument. So to calculate the value of alpha, we know that tan alpha is the opposite side divided by the adjacent side of our right angle triangle, and this is 3 divided by 6. So alpha is equal to 0.46 radians. So the argument of our complex number, argz, is pi minus 0.46. So if we calculate this out, we find that the argument is 2.68 radians. In our third example, we're going to look at finding the modulus and argument of the complex number minus 6 minus 3i. When we plot this complex number on the Argand diagram, we move 6 units on the negative real axis and 3 units on the negative imaginary axis. These form two sides of a right-angled triangle. The modulus z is the hypotenuse of this right-angled triangle and is seen here as the orange line. To calculate the modulus, we can use Pythagoras' theorem. So we need to take the square root of 3 squared plus 6 squared, which is the square root of 9 plus 36. So the modulus in this case is the square root of 45. The argument of the complex number is the angle theta shown here. Note here that we are operating in the third quadrant of the Argand diagram, and the angle theta runs clockwise from the positive real axis and is therefore a negative angle. The simplest way to find this angle is first to find the angle alpha, subtract this angle from pi, and then the argz is the negative resulting angle. So the tan of alpha is the opposite side over the adjacent side, which in this case is 3 divided by 6. So alpha is equal to 0.46 radians. The argument of the complex number is therefore pi minus 0.46 multiplied by negative 1. So the argument in this case is minus 2.68 radians. In this example, we'd like to find the modulus and argument of the complex number 3 minus 7i. If we plot this complex number on the Argand diagram, we see we move 3 units in the positive real axis and 7 units in the negative imaginary axis. These form two sides of a right-angled triangle. The third side, the hypotenuse, shown here as the orange line, is the modulus of the complex number. To find the modulus, we need to find the length of this orange line. To do this, we can use Pythagoras' theorem. So the modulus z is the square root of 3 squared plus 7 squared, which is the square root of 9 plus 49. So the modulus of this complex number is the square root of 58. To find the argument of the complex number, we need to find this angle theta. Note here we're working in the fourth quadrant of the Argand diagram. The angle theta is created when we rotate clockwise from the positive real axis. The angle theta is therefore a negative angle. So the argument of this complex number, or argz, is the negative value of theta. So to find theta, we can use trigonometry. So tan theta is equal to the opposite side divided by the adjacent side, which is 7 divided by 3. And theta is 1.17 radians. So negative theta, and the argument of this complex number, is minus 1.17 radians.